Hello everyone, welcome back to Z Physics. Today we're going to be talking about the motion of charged particles in a magnetic field. In order to illustrate this, I've drawn over here a little positive charge, and I'm positive that we're going to be analyzing its trajectory. Now let's get started. Let's imagine that this charge is moving over here to the right, and then suddenly it encounters a uniform magnetic field as illustrated over here. The direction of the magnetic field will be into the screen, and I'm just going to draw the little symbol for that just over here on the side, just to make that absolutely clear that the field is into the screen. Now, what's going to happen to this positive charge as it enters the field? So, as soon as this positive charge enters the magnetic field, we can use Fleming's left-hand rule to determine the direction of the force on the charge. If the field is into the board, and if our current is going to the right, this means that our force will be pointing upwards. So our force will be pointing upwards. Now notice something really important, and that is that the force will be perpendicular to the direction of the motion of this positive charge. Well, hang on a minute. If the force is perpendicular to the direction of motion, this means that this positive charge will be forced to move in a circle, because anytime we have a force which is perpendicular to the direction of motion, for instance, gravity in an orbit, or the tension force when we spin something on a piece of string, then this object will enter into circular motion, and this force will be a centripetal force. In fact, by setting the centripetal force equal to the magnetic force, we can even work out a formula for the radius of curvature. Let's do this. So all we need to do is set the centripetal force. So F centripetal will be equal to or will be provided by the magnetic force, like so. Now, our formula for centripetal force is just mv squared over r, where v is the velocity of the charge, and our magnetic force is qvb, like so. Notice that one of those v's is going to cancel out, so we can do this, and then we can just slowly in steps rearrange for the radius. So what I'm going to write down is that mv will be equal to qb times r, and finally I'm just going to rearrange for the radius, giving the equation giving me that the radius will be equal to mv divided by q times the magnetic flux density b. Notice that the radius of curvature is proportional to the mass of the particle and its velocity. It's also inversely proportional to the charge and the magnetic flux density. This equation actually is behind the working principles of the mass spectrometer, which is a topic for a whole different video. Okay, folks, well, hopefully you have enjoyed this one. If there are any questions, do let me know. And yeah, thank you very much for watching.